possible. So obviously this flaw thing isn't a flaw if it's part of the structure. I just mean that it's an aberrant thing. It's a thing the mechanics of the universe doesn't do. Most of the time it stays frozen, okay? And then it, for whatever cause, unfroze. But there had to be a cause, but it's a flaw in the system. It's a piece of dust. It's a piece of, a fragment. Who know? I can't give it a description. Um, but I guess at the same time, I can't explain the point of any of it. So part of me has to say, well, yeah, it has to be an aberration because it has no, um, there's nothing else to it. There's nothing else that would explain it. I mean, it can't be an intelligence because intelligence wouldn't do something like this. Intelligence wouldn't create ungoverned, uncontrolled. It would take responsibility for what it made. So there can't be intelligence behind it. So all I can say is it's a mechanical system, and a mechanical system that does this. This was possible, but that's, I'm just saying, I don't. It doesn't change the question for me, and it especially doesn't change the question if you stay focused on our origins, and we know where we came from, and we just came from a bit of chemistry that, pooped out a copy of itself that was reproducible, and that's it. So we're not special in our creation from matter. And if the entire universe was just matter with no sentience in it, well, then this would be a moot question because you wouldn't give a fuck. You wouldn't give eternity is irrelevant if there's nothing experiencing it consciously.
Yeah, but we're here, and it is trouble, and it's troubling for me, the idea of eternity. I mean, you went on about the sort of theories that I grew up with about, the possibility of the expansion and contraction and the cyclic nature of the universe. And that seems to be livable with for me. But it seems to have turned out to not be the case because the universe seems to be expanding ever faster apart. So that makes it even more troubling to me that that we can still think in terms that we was all compacted to some point, but when that point existed then for an eternity in the past, and then for some reason, I mean, you're talking an eternity of infinity in the past, and you're saying, well, I know you're not saying, we're all just guessing, but just, to me it's the same thing as something from nothing. To say it existed for an eternity in a stable state, and then all of a sudden it became unstable, if you follow me.
Yeah, well, like I said, I'm not saying it became unstable. What I'm just saying is obviously the instability is built into it. It does this thing. So it's like, engines will fail. Like a turbine on a jet will fail. And it's a very subtle reason. Obviously the reason was built into it. I mean, the defect was going to arise. And so it arose, and something catastrophic happens. But yeah, like I said, I'm not. This isn't something I spend a lot of time thinking about. Is all I'm saying. And the reason why I don't spend a lot of time thinking about it is because it's not a question I don't think we can answer. And it doesn't, in my opinion, it doesn't change the facts of our origins. We know where consciousness came from. We know it's just a tool that was of evolutionary convenience. And that's it. It's not magic or special, and so to me, that's where it ends. The universe would would be just as complacent, just as functional in doing what it's doing, whether it creates consciousness or doesn't create it. Obviously, from our perspective, we can appreciate that the consciousness makes a huge amount of difference, but the universe would have no knowledge of that difference. And so this was one of the possibilities. This is what the universe did this time, and it might be a one-time only event forever. Because all we know is it's an improbable event. We don't know how improbable. I mean, it could be preposterously improbable.
Here's something that I don't understand very well. Somebody can say, for example, that we, in fact, not faith, he says, we're also exposed to unnatural chemicals and substances. That always trips me up because I don't understand how you can say something's not natural if it's part of the natural world and it exists. Like, you could make the same argument and say plastic is unnatural because if it wasn't for us mixing chemicals, it wouldn't exist naturally. But, you know, we're natural creatures, and if it exists, no matter how unlikely for it to exist, it's still, to my knowledge, natural. So I don't.
Well,
That trips me up a little bit.
it's another word. It's a piece of our vocabulary that's broken, like the word freedom or the word spontaneous or the word random. It's a word that's just a little bit broken because the word natural for most people just means something separate from human creation, okay? Something that's part of evolution in the material universe and is separate from human interaction. So as soon as you apply human selection or something, you know, that's why it's called natural selection. I mean, it's because it's done out there by that forces, by those things, not humans. And so yeah, I mean, it's a word game in a lot of ways. I mean, so I think when most people are saying the word natural, they're making a distinction between something that we've created and something that 2 billion years of evolution created. So one's very stable. I mean, nature obviously has created enduring mechanisms. I mean, it's survived a long time. This evolution thing's been going on a long time, so by that standard it sort of worked. Obviously human beings have been here a very short period of time, and we've made a catastrophic mess, and so we're suspect because what we do, you know, is pretty reckless and sloppy and potentially dangerous and nuclear. I mean, you know, evolution doesn't create nuclear daisies. You know, it hasn't happened yet anyway. So I guess the difference is that, yeah, our constructs are oftentimes very hostile to stability.
All right, check this out. There's this guy on YouTube, and you were talking about, Gary, you were talking about like trash and nuclear bombs and all these sorts of things. Let me just focus on the trash part. There's this Japanese engineer who really took to heart the axiom. That's not me.
No, I was just singing along.
Okay.
Retard. Retard.
So,
retard. Retard.
yep. Yeah, no, so this guy, he's a Japanese engineer, and he took to heart the axiom of one man's treasure is another man's trash, and vice versa, reverse it, you know. But essentially what the guy's done is he's created a system, like a machine. All right, I'll try to get back to you on that. But in any case, he's a guy, and he literally goes out and he finds plastic in dumps and stuff like this, like bottles and bags, and he's created a machine that literally extracts usable oil from these pieces of trash. It's totally usable. He actually does an experiment where he takes the extracted oil from the plastics, puts it in a little bin or something, and lights it on fire. You can use this sort of stuff for like vehicles. It's just like oil, and it comes from the plastic, the petroleum from the plastic. I can find the link if you're interested, but
Well, yeah, well,
really,
whatever.
really
There's lots
cool.
of perpetual motion shit out there, lots of wacky theory. So I wonder how much energy he has to put in to reconvert the plastic back to petroleum. So that would be the question, is how much energy input is required.
Yeah, I did a little research on the internet too about like perpetual motion machines and stuff like that, and yeah, no, that's a misnomer. The term itself, it's impossible to have a perpetual motion machine. The best we can do is to invent something that you know, is a relatively perpetual motion machine. It's impossible to have a perpetual motion machine, but we can create something that's relative to our lifespan and stuff and the energy it takes to power it. It can be considered a highly efficient semi-perpetual motion machine. And
No,
yeah,
no, no, no,
kinetics.
no, no, no,
Yeah.
no, 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 no. No, there's no such thing as perpetual motion in a closed system. But what we can do is take advantage of things like gravity or other forces, okay, and extract value out of them with a machine that might look like a perpetual motion machine. So in theory, we could make a machine that could just function, do its thing, and produce energy, but it would really be extracting, it'd be converting gravitational forces or some other force into energy.
They do that with the water tubes that conduct electricity. They actually do that in Sweden. I think we could use kinetics as well. Like, I actually have this little radio light thing that winds up, and I'm thinking of rewiring it so that as my bike spins, I can hook it. It's going to take a lot, but so that as the wheels of my bike are moving, the motion is powering a charge cell, which is then also pulling solar electricity, which I have these strips, and so that I can charge a small battery that has 2 USB ports on it, so that I can go on a 100-mile bike ride and take my cell phone. Like, I know that sounds stupid, but it's a project that I've been working on.
Really,
but thank you.
This is old. You know, I used to deliver newspapers when I was a kid, so we're talking this, 1970, whatever. And yeah, I had one on my bicycle way back then. I had a little generator on my bicycle tire, and so it would create enough electricity to run a light, and so I could see. And so I'm just saying it's old technology. But this idea but it's always going to be conversion, and I'm just saying the idea of perpetual motion is trying to create some kind of mechanism that's so efficient that we can extract, like tide energy. There's lots of energy out there to be taken. It's for the taking. We just have to have an efficient mechanism to convert it through. It's like even something like lightning. I mean, tremendous amounts of energy if we can merely find some way to store it.
Yeah, I was going to ask the question to THX. They had these things, I saw it in Popular Mechanics or Science, but anyways, it's not important. What the thing is you have like the ocean, and it's got the tides and the waves. It's basically like snakes, and you put it on the waves, and the undulations of the waves are creating kinetic energy that's stored in some generator of some sort. Is that what you're talking about when you say these things? Is that what it is? You guys have those?
No, they can be created. That's like a small cell.
Yeah, she's just talking about recharging batteries. So you're just talking about a generator that recharges your battery. So yeah, I mean
exactly.
It's completely doable. They had wristwatches.
They already have them.
They've even had wristwatches been around a long time that recharge themselves, running the same principle. Okay, from the motion of your arm going back and forth, there's a little magnet. It goes back and forth in a coil of wire. Coil of wire generates a little bit of electricity. It charges the battery. It runs the watch for as long as the cell can be recharged.
What's cool about these things is they have two different types. One that stays on the surface of the ocean and just kind of has it looks like it's got like knuckles and joints and stuff, but it looks like a snake, and it just goes the waves, and the power of the waves it stores and it collects and stores and converts. But they also have these other things where you put them on the bottom of the ocean with the currents, and it's like a if you could picture one of those flippers that you'd use for diving, snorkeling. It looks like that, and it's on the bottom, and it moves with the currents, and that collects energy too. And they're already using these things too, so I think that's really cool.
Yeah, well, like I said, there's lots of technologies out there. There's also the difference in the temperature. There's from deep water, so there's lots of ways to extract energy. But it's not to me the biggest one is the hydroelectric one, the waterfall thing, and we could extract a lot of energy if we capitalize on that.